Hello learners, I am Dr. Munish Kumar Bhardwaj from School of Engineering and Technology, and today we will discuss about water treatment for smart cities. As you know, when we are living in the society, in any city or rural background, actually the most important thing is water, and we should get clean and safe drinking water. This is the requirement basically. So whether we are living in a general city or a smart city, water is the prime requirement, and that water should be safe, potable for our drinking purposes basically. So here, what is the need for safe water? What is the need for water treatment basically, and how it is done? So we will focus around this theme basically. What we will cover in this, that what is the need for treatment of water first of all, then we will talk about the treatment units. What are the different units which are used for the treatment of the water basically. The learning outcomes for today's lecture are that after this lecture you should be able to explain the need for treatment of water, and also you should be able to describe different treatment units, their purpose and their functioning. So let us begin with the need for treatment of water. Why we treat water basically? So that we can supply a safe drinking water to all the habitants of a particular region basically. So this is the purpose of treatment of water. And by means of treating water, what we do, we try to remove all forms of impurities, which are physical impurities, chemical impurities, and the biological impurities. So these all impurities, which are categorized or divided into three groups basically. So the purpose is to remove these impurities from water so that we can make water safe for drinking purposes. Because say water which is not safe for drinking purposes may cause a lot of diseases in the population. First of all, let us see what are the different groups of the treatment units, or you can say that in how many groups the all different treatment units can be classified or grouped. Basically all the units which are used for treatment of water may be grouped or classified into the two broad groups basically. First one is the unit operations and second one is the unit processes. What is the difference between this unit operations and the unit processes? Unit operations, what they do basically, that removal of impurities from the water by action of physical forces. What are these? Like screening. Screening is a unit. I'll tell you later all the units basically. Another one is sedimentation. Here we are not, in these units we are not using any chemicals. So that way by means of physical processes we are removing the impurities present in the water. So these are the unit operations basically. Second is unit processes. In unit processes we take help of some chemicals for removing the impurities. So that way we call it as a unit processes, because some process is involved with the help of some chemicals basically. So this is the difference between the unit operations and the unit processes. So all the units can be classified or grouped into these two groups basically, unit operations and the unit processes. So just look at this figure basically. This gives you the flow diagram for all the treatment units, that where from we take the water, then how we treat water. So these different units for the treatment of water are given here. So if you start from here, so this one is your source of water, you can say, or the water intake basically. So here, from here, we are taking water. The source of water may be two, basically surface water or groundwater. So when we are taking surface water, so there may be lot many impurities in it. These impurities may be floating impurities, means floating objects just like leaves, tree branches, some other objects, papers, cloths, something they may be there basically. Because it's a surface source, so in this surface source, these impurities may be there. So first of all, when we are taking this water, then it is pumped to the different units basically. The first unit that comes into the picture is at the near the source only, where we are using the screens basically to remove the floating objects basically. So first we are removing the floating objects, then the water is pumped to another units. Another unit is here the coagulation. Coagulants are chemicals which are used to remove the suspended impurities. Then it is sent for the aeration and sedimentation. Here all the settleable matter settles here in the tank, which is removed from water. Then after this is sent to the activated carbon and sand filters basically. So this is the filtration process. Then after filtration, the water is sent for the disinfection and the final treatment. Disinfection is basically if some bacteria or pathogenic organisms, microorganisms are there, so water is not safe. So just to kill any pathogenic bacteria or other microorganisms, here the disinfection is done basically, and this disinfection, for this disinfection we use generally chlorine and some other chemicals also. Then after disinfection, some secondary treatment of UV through UV rays we can do, and finally we get a safe water which is then sent for storage, and from there this is water is distributed to the houses of the people basically for drinking purposes or other purposes. So this is the flow diagram, that how water is taken from the source, then how it is treated in the different units, and how it is supplied to the households basically. Flow chart, the similar process is shown here through flow chart. This is a source of water, then intake well, then screens for removing the floating objects, then aerators, then coagulant tanks where coagulation is done, then mixer, flash mixer, then flocculation. Here that settleable matter is removed basically. Then filtration, where filter beds, these are generally sand filters. Then disinfection, as I told you. Then distribution system. So this is a flow chart of the same thing which you saw as a diagram. Now let us see different units basically. So first in the process is screening process basically. As I told you, the purpose is to remove the floating substances or floating objects. The aim of screening is to remove the solid materials. Why? Because if solid material is there present in the water, then it can contaminate waterways. It can cause damage to other process equipments like our pumps and other equipments. Then also it can cause a reduction in the efficiency of the whole system. Whole system means the treatment system basically. So just to avoid, so that solids which are present in the water or floating objects present in the water do not interfere with the functioning of the other units, we are removing these solids and the floating objects from the water. Let us see what are the different type of screens. How we classify the screens. The screens are classified into three groups basically. One is fine screens, which are having openings less than 6 mm. Then coarse screens, where the openings is between 6 mm to 150 mm. And third type is micro screens, which are having openings less than 50 microns. So these three type of screens are used. Generally for floating objects, first coarse screens are placed. After that, we can place the fine screens for removing some solid things or solid particles, basically up to the size of 6 mm basically. So here you see the picture of the coarse screens. Basically these screens are bar screens basically, which are metal or iron plates, or that bars are there. So the floating objects are stuck in these screens basically, and from there it is removed. Fine screens, these screens are used to remove the fine solids from the incoming water. Opening of these screens is less than 6 mm, as I told you. Fine screens may consist of wedge wire elements, wire cloth, and perforated plates. This is the media which is used for the fine screens. Then fine screens are classified into three categories based on that their functioning: static or fixed wedge wire screen, then rotating drum screen, then step type screens. So these three type of fine screens are used in the water treatment process. Then you see here the static wedge wire screen, how it looks like. This is the picture of this static wedge wire screen. Here the opening is 0.2 mm to 1.2 mm. Larger floor area is required for their operation, and they need to be cleaned once or twice per day, because here the opening is small. So here regular cleaning is required for their effective functioning. Otherwise these screens are blocked, then that proper functioning will not happen there. So that blocking or that clogging of these screen has to be removed by cleaning from time to time. Here you see the rotating drum screen. In this drum screen, a straining medium is mounted on a cylinder which rotates in the flow channel. Here you see there is a drum, and on this screen is mounted basically, and it rotates in the flow channel or water channel basically, and when it rotates, water passes through it, and any object which is there, solid object which is present in the water, that is stuck in these screens, and it is removed from water, and that solid is not there in the water which is passing out from these screens basically. Then coarse screens, these are also called as trash racks. As I told you, here the opening is 6 mm to 150 mm, means the large openings are there. These are made up of wires, rods, wire mesh, parallel bars, or a perforated plate having openings of the shape of rectangular or circular. These are sometimes placed in front of fine screens to remove larger solids that may clog or cause any damage to the other appurtenances or the equipments. So to safeguard other equipments, these screens are placed in the water channel so that any bigger floating object is trapped basically and removed from water. Now let us see that classification of coarse screens. Coarse screens are of two types depending upon how they are cleaned basically. One is hand cleaned screen, which you see on the left. This is the hand cleaned screen. This equipment we use for cleaning basically. Once any object is stuck here, so through this rod we are cleaning these screens. Second is mechanically cleaned screens that you see on the right basically. Here the motors are there for movement of this brush, which cleans any object which is stuck in these screens. So these are the two type of screens depending upon that how we are cleaning the screens basically. Then next unit is after the screening, the next unit is sedimentation. So in screening, what we are doing, we are removing the floating objects, large solid objects basically. But after removing all these floating objects, there are objects or the particles which are in the suspended form, but which can settle if we can reduce the velocity of flowing water, then some of the solid objects or the solid particles can settle. So this is the purpose here, that the particles which are moving with running water, these solid particles have to be removed basically. And the basic principle is that if we can reduce the velocity of flowing water, or we can allow water to rest for some time, then these solid particles can settle and that these particles can be removed from the water. So here, what type of solids are removed? Basically, inorganic suspended solids are removed here by the action of the gravity, means by weight, because if we are reducing the velocity of the flowing water, that solid particles may settle due to the gravity by their own weight basically. And from the bottom of the tank, we can remove these solids basically. So this is the basic principle. So as you can see here in this picture, just look at this picture here. There is a tank here. Tank is shown here. And in this tank, what is happening? In this tank, just look at this tank. Water is coming from the left, and you see here the brown round particles. Basically, these are the solid particles which are coming along with running water. So in this tank, what happens that velocity is reduced basically, means, and also the water is allowed to remain for some time, which is called the detention period basically. So for that detention period, water is allowed to remain in this tank, and because of this reduced horizontal velocity, now the solid particles due to their own weight settles into the bottom of this tank, and from there these solid particles are removed and clean water goes for further treatment processes. So this is the functioning of this sedimentation tank. The efficiency of tank depend on the detention time. Detention time is the time for which water remains in this tank basically. These tanks are rectangular or circular in shape. Suspended solids are having size of 10 micrometer and greater, and the colloidal particles are of size between 1 nanometer to the 1 micrometer. So here means there are two type of particles are there after screening basically, solid particles, inorganic particles. One is suspended particle, another one is colloidal particles. Colloidal particles are finer than the suspended particles. So we have to remove those inorganic solid particles which can settle in the tank when we are reducing the horizontal velocity or velocity of flow of the water. So this is the way how we reduce it. Then settling of these particles in sedimentation tank depends upon, first of all, size of particle. There are some factors on which this settling of these particles depend. First is the size of particle. Larger the particle, then more quickly it will settle and can be removed. Then specific gravity of the particles. Heavier the particles, they can be removed easily. Then viscosity of fluid or the liquid basically. So here the water is there. So if pure water, if that impurities are there, viscosity will increase. If water is a bit clean, then viscosity will be less, and in less viscous water, the particles will settle easily, more quickly. Then third one is the velocity of flow of water through tank. Lesser the velocity, more effectively these solid particles will settle. Then detention time. More the detention time, then the particles can settle easily. So these are the factors on which this settling of these particles depend, or the efficiency of the sedimentation process depend basically. Also, this settling of these solid particles depends upon the Stokes law. Stokes law says that the settling velocity of the particles depend upon the diameter of the particle and also the viscosity of the liquid. How it is related? Settling velocity of the particle proportional to the square of the diameter of the particle, d square, and it is inversely proportional to the viscosity of the liquid. Means larger the diameter, settling velocity will be more, and if the viscosity of the liquid is higher, then settling velocity will be less, because here the relationship with the viscosity is inversely proportional. So that way reverse thing happens basically. Now how these sedimentation tanks are designed basically. So two things are important here. One is the velocity of flow and second thing is the settling velocity. So if we take a tank of rectangular shape basically here, so length L, width B and the height H, and if Q discharge is flowing, so the area through which it is flowing, this will be B into H. From this face it is entering, from this face it is coming out basically. So for that, discharge can be calculated as you know that discharge is volume upon time, that how much volume is passing through in how much time. So discharge is volume upon time. So volume is of this tank is L into B into H divided by time in which time it is flowing basically. So Q discharge will be L into B into H upon T. The area of flow of this face is B into H, through which it is flowing basically. So the velocity of flow will be horizontal velocity I am talking about, that Q discharge upon the area, because discharge upon area is the velocity. Now the time of the horizontal flow means how much time it will take from entering this face to the exit from this face. So this, how much time it will take, that you can calculate as length traveled divided by the velocity. So length traveled is the length of the tank, which is L basically, and the velocity we calculated here as V equal to Q by BH. So that way we can calculate the time of the horizontal flow, which comes out to be LB into H upon Q. So LBH, you know, it is the volume of the tank. So time of the horizontal flow you can calculate as the volume of the tank divided by the discharge basically. If the settling velocity is Vs, then here time of falling through the depth H, means here any particle which is there at this level basically in the water, this has to come at the bottom. So how much distance the particle has to travel? This is H basically. So this distance, if the settling velocity is Vs, then distance upon this velocity, that will be the time taken. So here this time taken for settling of a particle is H upon Vs. The particle will be removed if the time of falling through is equal to the detention time. Means the time for which water remains in the tank and this time taken for a particle to settle to the bottom of the tank basically. So if this time taken by the particle to go to the bottom of the tank, if it is less than the detention time, then it will be removed. Particle will be removed. Particle will settle in the bottom. Otherwise, it will flow along with the water basically. So this is the way how we design the, or you can say this is a principle based on which we design our sedimentation tank. So after sedimentation, then this water is sent for basically flocculation, coagulation and flocculation. Because in sedimentation tank, all the colloidal and suspended particles may not be removed. There may be some fine particles which remain in colloidal or the suspended forms. So to increase their size, we add some chemicals in water, basically, which are called coagulants. And their function of coagulant is to increase the size of these particles by bringing the fine particles together and make them heavy so that they can settle, basically. So by coagulation and flocculation, we try to remove the very fine particles which remains in the suspended or the colloidal form. After flocculation, as I told you that this water is sent for the disinfection, for filtration, basically. Here the sand filters are used. Through the sand bed, water trickles basically, and any impurity which is there in the water, that it's trapped in the sand filters basically. Then we get a safe water. Then there may be some bacteria or microorganisms. They are removed by disinfection process, in which generally we use the chlorine, and finally we get the safe water. So this is the process by which we treat water to make it safe for the drinking purposes. I hope that you will go through the text or the self-study material that is given to you, and you can go into that more depth of these concepts given in the text. Thank you.